Good afternoon, everybody. Thank you very much for joining this session. I'm Michal Slusarek from Deloitte Consulting.
Grzegorz Karlik from Wrocław Waterworks.
Every day, over 1 million people in Wrocław and around turn on a tap, take a shower, flush a toilet, not even thinking what it takes to make it happen. And underneath the ground, underneath the feet, there's 5,000 kilometers of infrastructure. And like every infrastructure, it ages. And when it ages, it fails, it breaks down. Historically, the maintenance was when something breaks, you fix it. But what if we could change it? What if we could predict where, what, and how it's going to fail and what to do about it? And that's the story we'd like to tell you today. The story of a project that was done together by Deloitte with Wrocław Waterworks on AWS. This is a story where the data science, knowledge, operational knowledge of Wrocław Waterworks and the power of cloud solution of AWS helped to really change the way the business is being done in a very practical manner. And this is the case about Waterworks, but thinking about it as a blueprint for any infrastructure project, be it transport, gas, energy. Grzegorz, tell us how it all started.
Thank you, Michał. I would like to explain why we use predictive model in our company and how we use it in our daily operations. As strange as it may sound, predictive model is connected with the history of waterworks. It's strange because we should say something about AI predictive analytics, but believe me, reason why we use predictive model is deeper in our history. History of modern sewage and water systems began in the 19th century. That was the time when infrastructure of modern cities were established. You can see on the picture pumping station that was built over 150 years ago, and that was the beginning of new modern water network in our city. And the history of our company is not so different than the history of any large or big city in Europe or in so-called developed world. Such pumping station make it pipes pressurized, large-scale network emerged. That was the beginning of the modern infrastructure of every city. And of course, after many years, it have expanded and upgraded. These figures show that we have some kind of challenge around the world because the core issue in the world is the gap between how fast network deteriorates and how fast we can afford to renovate them. Still, we have the same problem in our cities. The cities evolved, technologies changed, organizations have modernized, but we still have one thing in common. Part of our networks has the beginning in the 19th century and still it's operational. So part of our networks is exactly the same like it was built in the 19th century. And that's in a global scale is a challenge around the world. It's called aging infrastructure, and in waterworks we still have pipes that were built in the 19th century, operational, delivering water to our customers. Of course, that's this gap between what funds we have and what needs we have to cover it. It's a challenge for us and many waterworks around the world. We can say that Wrocław has modern networks. It's a modern company using innovative technologies supporting our operations, but this is the problem we still have in our network. Still, we have over 40 kilometers of the network that go back to the 19th century. And many sections of the network exceeded their 100-year lifespan. In theory, that's the time that no pipe should exceed, because that's the time when pipe is working properly. And after this theoretical time, you should renovate, rehabilitate pipe, because it's too much. That's the theory. But we know that we should and we have to use our pipes more than 100 years, because we still have this gap between the funds and the needs we still have in our company. Of course, there is another obstacle. All our networks are hidden underground, so it's really difficult or incredibly challenging to assess their condition directly. That's why we need smart tools, AI support to evaluate their condition. This is how large pipe breakdown looks like. It's a nightmare for a water operator. One moment everything is fine, next pipe will suddenly burst, huge stream of water like a river flows through the city, streets are flooded, basements fill up, buildings get damaged. And this is, of course, a technical issue, because, and of course, economic issue, because private and public property is damaged. It's very expensive to remove results of such breakdown in our city, but such scale of such dramatic events make it a media event also. And it raises questions about how do we manage our networks? What is the condition of the network? What is the reason of the breakdown? And we see the goal for predictive model right here, to warn us about such weak spots in the network, to identify risky parts of the network before something happens, just to make it possible to plan smarter, act earlier, and avoid such worst case scenarios. In our company, every project we take on should stand on two main pillars: operational efficiency and social responsibility. Every project should be aligned with our strategy and goals connected, like water loss reduction, lowering cost of operations, increasing customer satisfaction, protecting the environment. And we feel that predictive model fits perfectly with this strategy, because it solves not the short-term problem, it's not for today. It's aligned with our mission, and our mission is to serve people of our city. Our networks supposed to serve for 20, 50, 100 years from now. And that's why we need predictive model to sustain this water delivery in our city in such horizon. For many years, we implemented international standards to reduce water losses. Standards established by AWS, it is organization gathering scientists, engineers, practitioners in water and sewage sector. Why water loss? Water loss is the main indicator that can show you how efficiently you manage your water network, how good you are at taking care of networks assets. And for many years, that was our strategic goal, to limit water losses to the lowest possible limit. And we successfully used and implemented tools from this international methodology, like pressure management, active monitoring, speed quality of repairs of our field teams. That's very sophisticated and highly advanced tools, but one thing is still ahead of us. It's still not complete. Full rehabilitation of the water network. This is the most ambitious, but also most expensive tool to implement because it needs massive investment in vast infrastructure. So it's not easy to use it because hard to believe that we will replace all of our network at once. We need support of predictive analytics to assess condition of our networks and pinpoint to the sections that are responsible for water losses that have the greatest impact on water losses. 2014, we decided to launch the whole pack of projects that was dedicated to lower our water losses, and we've made a real progress. Right now, our water loss level is 5%, and that's the result of the best European companies. But to push it further from this level to even lower levels, it's really hard, and we need more innovative projects like IoT networks, for monitoring systems, for smart meters, to derive data from such systems and use it in this fight with water losses. But what is most important, we need to renovate networks responsible for water losses we don't know about right now. And that's why we need predictive analytics to show us where to invest, where we should invest our next strategic tasks, strategic investment in the network, these risky parts that can be showed by predictive model. Generally, we can say that every problem can be solved with money, but of course the real problem is there is never enough. And a couple of years ago, we estimated our needs related to both networks. We evaluated the most fundamental needs of our networks and to have the big picture, how much money we need to spend to fix all the problems we have in our city. In this exercise, we assumed that over 10 years, we should renovate, rehabilitate all the networks that have these fundamental needs. And the results were clear. We don't have money to do it. We don't have money to do it at once, but also in this horizon of 10 years, we still don't have money to do it. And that's why we need to pinpoint which section of the network is crucial, how to prioritize our needs, because we don't expect great money to appear in our company, but still we need to have plan how to deal with these crucial parts of the network.
Thank you, Grzegorz, for the introduction of the context. And this is where we started our discussion and started our project. Actually, at the beginning, we took whatever data on the network historically Waterworks had. It was unstructured, so it was a challenge one to make it structure, and then enrich it. There is a wealth of proprietary and also public data that we add on to the information we got from Waterworks. We developed a very extensive database for each section of the infrastructure with over 300 variables. And then the power of the AWS kicked in. We are able to develop and test a large number of machine learning models that were helping us to achieve nearly 90% accuracy of the prediction where and what is going to fail. And surprisingly, when we discussed it with the engineers, factors that never were taken account, like the intensity of traffic over or the concentration of the restaurants around the pipe, were important factors to the information whether the network gonna fail or not. Last but not least, we are able to identify what were the root causes of the potential failure. And most importantly, for the organization, for Waterworks, we're able to develop a financial modeling tool that not only told us what could fail, but actually how much it's gonna cost to repair it, therefore to be able to optimize the planning and the budget of the client. And this is the work we did. And Grzegorz, please tell us how it works in practice.
Thank you. How we use it today in our company. Maybe before I say how we use it, I will say traditionally, in the past, how it was done to pinpoint the section of the network that was supposed to be renovated. The long-time employees were responsible to show which areas or which section of the network are causing problems, often by looking at the past failures in the network under a given street. That was the reason, that was the cause of and the base of our plan. And of course, it could be done that way, but in a small system, in a large city like ours, it's just not enough. The model shows us that there is mixture and combination of factors that are responsible for breakdowns. And of course, it's impossible to analyze all the data that model can analyze for any human operator. It's just too much. And the model can do it in a very easy way. It's not necessary to be engineer to understand the results that model can show us. As you can see on the screen, having a section of the network in the right color, red one, for example, you can see that there is a problem. The probability of failure in the future is quite high, and you should take care of the network that was highlighted this way. Of course, there are many reports that can prioritize the sections of the network to have the base for the plan of renovation in our company. Like I mentioned before, our networks are buried on the ground. So that's the challenge. And around them, we have all sorts of soil types, water levels, exposure to weather, temperature. Around them, we have roads, tram tracks, even trees. And the network itself is a patchwork built over many decades with different materials and construction methods. All of these factors can affect how many numbers of failures occur in the network. And what is impossible for a human operator, it can be done using AI tools and predictive models, because model looks at all of these variables, all of them, and find the pattern that matters most. And this way can show us which part of the network is a high-risk network we should take care of. In the end, we need a plan, reliable, data-driven plan, and of course based on risk, not just expert assumptions, because experts, even the best one, can miss the bigger picture. And we have such plans. So we have prioritized networks, sections of the network. Every section of the network has assigned estimated renovation cost, and it's based mostly on tasks and works we've done in the past. So we have our network prioritized, and we've assigned costs that are based on our past works. That way we have planned that is both strategic and realistic, so we can do the most crucial needs in our company using our regular budget.
Thank you, Grzegorz. This is an example of the project that we managed to successfully deliver with Wrocław Waterworks on AWS. And this is a blueprint, a playbook. It all starts with the conceptual work, so analysis for a specific client of a specific industry, what data is available, how the data needs to be enriched, and making sure that the organization we are working with is fully on board. Then comes the data science piece, so structuring the data, building the models, testing, learning, and making sure that the quality of the output is relevant for organization and really can help the organization to work on it. extremely important financial model. This was originally not the part of the project, but we found that it's very important for it to be practical, to be implementable. So the ability to optimize the investment budget, the ability to prioritize and understand how much it's going to cost was very important part of the project. And last but not least, Grzegorz mentioned that the job so far was based on the experience of the most seasoned engineers. It was extremely important to making sure that people that were doing same approach for last 20, 30 years were open to a change. And this was a very important factor of this project, to build the trust and build the understanding and integrated the project into the daily work of the organization. So the cooperation and collaboration was the key success factor. Collaboration between Deloitte and Waterworks, ability to find appropriate solution and services for AWS, making sure that we have a joint team consisting of people with experience from Waterworks, data science experts of Deloitte, and technology people from AWS, and then to be able to calibrate the system. Think of it as a blueprint for any infrastructure project. This is specific for Waterworks. A similar approach can be done for transport, gas, heating, energy. Any infrastructure needs predictive maintenance, because this is the way things are being done these days. Thank you very much for coming, for listening. We are happy to talk and discuss. Thank you.
Thank you very much.